Hello friends, I am Sanjay Bhusal, Assistant Professor, Department of Electronic Science, Sangamner Nagarpalika Arts, DJ Malpani Commerce and BN Sarada Science College, Autonomous Sangamner. Today in this video, we will explain the number system conversion techniques. There are 4 number systems, weighted number systems. First one is decimal, then hexadecimal, then octal and binary. We can convert any number from other 3 weighted number system, that is decimal number is converted into hexadecimal, octal or binary. Similarly, binary is converted into decimal, hexadecimal, octal. Hexadecimal is converted into decimal, octal and binary, and octal is converted into decimal, hexadecimal, binary. Today we will see how binary number, octal number, hexadecimal number is converted into equivalent decimal number. For this presentation, first is binary to decimal conversion, second octal to decimal conversion, and third one is hexadecimal to decimal conversion. First conversion technique is binary to decimal conversion, that is how binary number is converted into decimal number. For binary to decimal conversion is performed simply by writing weight of sum equation for given binary number in terms of power of 2. Then after solving this equation, we get required decimal equivalent. As binary number is having base 2, so we write weight of sum equation for binary number in terms of power of 2. Here one example how weight is assigned to the binary bit position. First number is 1001101.101. This is the binary number. Starting from this binary point towards left direction and right direction, first digit is having positional value 2 raised to 1, second digit is having positional value 2 raised to 1, then third digit is having value 2 raised to 2, then so on up to last digit there is positional value 2 raised to 6. Towards right, first digit is having positional value 2 raised to 1, second digit is having value 2 raised to minus 2, third digit is having value 2 raised to minus 3. Then 2 raised to 0 equals to 1, 2 raised to 1 equal to 2, 2 raised to 2 equal to 4 and so on, 2 raised to 7 equals to 128. Then how we convert this binary number into equivalent decimal? Example is 1001101. This number is converted into equivalent binary number. First we have to write weight of sum equation for this number. This 1 is having positional value 2 raised to 0, the 0 is having positional value 2 raised to 1, 1 is having value 2 raised to 3 and so on. This 1 is having positional value 2 raised to 6. So we write weight of sum equation as digit into positional value plus next digit into positional value as 1 into 2 raised to 6, 0 into 2 raised to 5 plus 0 into 2 raised to 4 and so on up to 1 into 2 raised to 0. And after solving this equation, 2 raised to 6 equal to 64, this term becomes 0, next term is again 0, then 2 raised to 3 equal to 8, 2 raised to 2 equal to 4, then next term is 0 and last 2 raised to 0 equal to 1. By adding this equation, the decimal equivalent is 77, that is this 1001101 binary is equivalent to 77 decimal. The second example 1101.101. again here we write positional value for each digit, that is this one, first one is having positional value 2 raised to 4, second one is having 2 raised to 3 and so on, last one is having positional value 2 raised to minus 3. So, we write weight of sum equation as 1 into 2 raised to 4, that is digit into positional value plus next digit into positional value up to last digit. So, 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 up to 1 into 2 raised to minus 3. So, 2 raised to 4 equal to 16, 2 raised to 3 equal to 8. So, this term becomes 0, then 2 raised to 1 equal to 2, 2 raised to 0 equal to 0 plus 1 into 2 raised to minus 1 equal to 1 half plus 0 plus 1 upon 2 raised to minus 3 is equal to 1 upon 8. So, this 16 plus 8 equal to plus 2 equal to 26, 1 upon 2 equal to 0.5 and 1 upon 8 equal to 0.125. So, this total value becomes 26.625. So, this binary number 11010.101 is equivalent to 26.625 decimal. Then we see second conversion technique, octal to decimal conversion. Octal to decimal conversion is performed simply by writing weight of sum equation for given octal number in terms of power of 8. Then after solving this equation we get required decimal equivalent. So, for octal number the weight of sum equation is in terms of power of 8, because the base of octal number system is 8. So, positional value for octal number is represented in terms of power of 8. First example is 432157.63. This is octal number and we can write positional value for this number starting from this octal point, go towards both direction. This unit place digit is having positional value 8 raised to 0, then second place value digit is having value 8 raised to 1, then next one is having positional weight 8 raised to 2, this 2 is having positional weight 8 raised to 3, this 3 is having positional weight 8 raised to 4 and this 4 is having positional weight 8 raised to 5. Then this 6 is having positional weight 8 raised to minus 1 and this 3 is having positional weight 8 raised to minus 2. So, 8 raised to 0 equal to 1, 8 raised to 1 equal to 8, 8 raised to 2 equal to 64, 8 raised to 3 equal to 512, 8 raised to 4 equal to 4096, 8 raised to 5 equal to 32,768, 8 raised to minus 1 equal to 0.125, 8 raised to minus 2 equal to 0.01562. Then we see the one example. This 4357 octal number is converted into equivalent decimal. First we write the weight for each digit. So, this 7 is having weight 8 raised to 0, this 5 is having weight, positional weight 8 raised to 1, 3 is having positional weight 8 raised to 2 and this 4 is having positional weight 8 raised to 3. So, we can write weight of sum equation for this number as 4 into 8 raised to 3 plus 3 into 8 raised to 2 plus 5 into 8 raised to 1 plus 7 into 8 raised to 0. So, 4 into 8 raised to 3 equals to 4 into 512 plus 3 into 64 plus 5 into 8 plus 7 into 1. So, this 4 into 512 equals to 2048, 3 into 64 equals to 192, 5 into 8 equal to 40 and 7 into 1 equal to 7. By adding this we get 2287, that is this 4357 octal is equivalent to 2287 decimal. So, next example for octal to decimal conversion is 64.25 octal is converted into equivalent decimal. So, we write first weight for each position starting from this octal point. This 4 is having weight 8 raised to 0, this 6 is having weight 8 raised to 1, this 2 is having weight to 8 raised to minus 1, and 5 is having positional weight 8 raised to minus 2. So, from this we can write weight of some equation as digit into positional value. First term becomes 6 into 8 raised to 1 plus next digit into positional value as 4 into 8 raised to 0 plus 2 into 8 raised to minus 1 and last term is 5 into 8 raised to minus 2. Then putting the value 6 into 8 plus 4 into 1 plus 2 into 0.125, 5 into 0.01562. This 6 into 8 becomes 48, then 4 plus 0.25 plus 0.0781. By adding this term we get 52.3281. So, this 64.25 octal is equivalent to 52.3281 decimal. Then third conversion, hexadecimal to decimal conversion. Hexadecimal number is converted into equivalent decimal by simply writing weight of some equation for given hexadecimal number, and this weight of some equation is written in terms of power of 16 as the base of hexadecimal number is 16. So, we can write the weight of some equation in terms of power of 16, and after solving this equation we get a required decimal equivalent. Then example, this 9A21F7.D3, this number is having positional weight in hexadecimal number system is this 7 is having positional value 16 raised to 0, F is having positional value 16 raised to 1 and so on. This 9 is having positional value 16 raised to 5, this D is having positional value 16 raised to minus 1, 3 is having value positional 16 raised to minus 2. So, 16 raised to 0 equal to 1, 16 raised to 1 equal to 16, 16 square equal to 256, 16 raised to 3 equal to 4096, 16 raised to minus 1 equal to 1 upon 16 equal to 0.0625, 16 raised to minus 2 equal to 1 divided by 16 raised to 2 equal to 0.003906. In hexadecimal there is some alphabets, for example capital A is equivalent to decimal 10, B is equivalent to 11, C is equivalent to 12, D is equivalent to 13, E is equivalent to 14 and F is equivalent to 15. This value is also required for solving the weight of sum equation. First example is 59B7. This is the hex number. We have to convert this number into equivalent decimal. For this 7, the positional weight value is 16 raised to 0. This B, second digit, is having positional weight 16 raised to 1. This 9 is having positional weight 16 raised to 2, and this 5 is having positional value 16 raised to 3. From this we write weight of sum equation as 5 into 16 raised to 3 plus 9 into 16 raised to 2 plus B into 16 raised to 1 plus 7 into 16 raised to 0. So, 5 into 4096 plus 9 into 256 and this b is equivalent to 11 into 16 plus 7 into 1. So, this term first term 5 into 4096 becomes 20,480, 9 into 256 becomes 2304, 11 into 16 becomes 176 and 7 into 1 is equivalent to 7. After adding this we get 22,967 as a decimal equivalent for hexadecimal number 59B7. The next example of hexadecimal to decimal conversion, that is 9F7.D3. Hexadecimal is converted into equivalent decimal. So, this 9F7.D3 having positional value 7 as a 16 raised to 0, F as a 16 raised to 1, 9 as a 16 raised to 2. This D is having value 16 raised to minus 1 and 3 is having positional weight value 16 raised to minus 2. Then we write weight of sum equation for this number as 9 into 16 raised to 2 plus F into 16 raised to 1 plus 7 into 16 raised to 0 plus D into 16 raised to minus 1 plus 3 into 16 raised to minus 2. By putting the value 9 into 256 plus 15 into this F is equivalent to 15. So, 15 into 16 plus 7 into 1, this D is equivalent to 13. So, 13 into 0.0625 and 3 into 0.003906. After solving, first term becomes 2304, then 15 into 16 becomes 240, then 7 plus 0.8125 plus 0.0108. After adding we get 2551.82332, that is this 9F7.D3. This hexadecimal number is equivalent to 2551.82332 decimal. So, in that way we can convert any number. Last example is 8A.9F. This A is having positional value 16 raised to 0, 8 is having positional weight value 16 raised to 1, 9 is having positional weight 16 raised to 1 and F is having positional weight 16 raised to minus 2. So, we can write weight of sum equation as 8 into 16 raised to 1 plus A into 16 raised to 0 plus 9 into 16 raised to minus 1 plus F into 16 raised to minus 2. So, 8 into 16 plus 10 into 1 plus 9 into 0.0625 plus 15 into 0.00390. This A is equivalent to 10, this F is equivalent to 15, and after solving this equation we get 138.62199 as a decimal equivalent for 8A.9 F. Thank you.